Hello and welcome to today's lesson, which will be on the very basics of algebra. First of all, apologies that it's been a gap of 4 weeks. I went away for a bit and then I've been busy doing other things and completely forgot. But I'm back now. Hopefully you haven't missed me too much. So, what is algebra? Simplest form. Algebra is basically solving equations or other things with unknown quantities. So, for example, in maths before, hopefully you will have seen something like 3 plus 4 equals 7. That is a statement, that is a true fact, you know that. That's great. In algebra, we deal with things that might look like 3 plus x equals 7. And in those cases, we're interested in, well, what values of x make that expression true? I'm throwing a lot of terminology around, which I will explain just a sec. So an algebraic expression is just anything that has unknowns in it. So x is an algebraic expression. I should point out now, we normally use x and then later y and z and then sometimes w if it gets that really crazy to denote these unknown quantities. This is mainly because most of the other letters have some meaning. So for example, we don't use, we don't use e because e is a mathematical number. E equals 2.71828, etc. It goes on forever. There are mathematical ways of defining it, but it has a set value, so we wouldn't say something like 3 plus e equals 7 because to most mathematicians e is that 2.718. It does not represent an unknown quantity. Also, a lot of this is science's fault. Boo, no one likes science. I'm sure you all like science. Science is great, but obviously science uses a lot of letters to denote various units and other quantities. So for example, I can't think of any off the top of my head now, but we've got things like A for amps, V for volts, all that stuff. And if you get into particularly physics, which is very equation heavy, you get all your crazy equations like V equals IR, P equals W times T. I don't know, it's been a while since I've done physics. But basically, what you never see in those equations are x and y, very rarely z, and w because we needed a fourth letter. Additionally, you will have seen me writing x like that. That is normally how most mathematicians write x when they mean an unknown variable or quantity. Obviously, this distinguishes between that x, which is a multiplication symbol. So I wrote 2 times 2 like that. Obviously that's just 4. If I wrote 2x like that, that's something different. So that is an algebraic expression, anything with an unknown. So x, x plus 5, x minus 2. How we could do the square root of x times 724 over 9. That's still an algebraic expression, although I wouldn't fancy working with it. The next term we need to talk about is an equation. An equation is quite simply, like we saw earlier, something like 3 plus x equals 7. That is an equation. Why do we call this an equation? Well, mathematicians are original. It's an equation because it has an equal sign. That's all there is to it. So an expression is just the term. To make it an equation, we say it equals a set value. So here, 3 plus x is an algebraic expression. It changes, so if we put in a value for x, we get a different value out. Put in a different value for x, we get another different value out, etc., etc. We put in an equal sign and something on the other side of that equal sign. This is no longer an expression. We are specifically considering the case where that equation is true, which in this case is obviously when x equals 4. contrasted with an equation is what's called a function. Now a function is something like y equals x plus 3. You may well have seen these in graphs or other places. Sometimes mathematicians write this as f of x, where f of whatever just means a function of that variable. So if I wanted, I could make up some lovely squiggle and say f of squiggle equals squiggle plus 3, and that means exactly the same thing. Obviously, squiggles are a lot less well defined in anyone's handwriting than an X, so we tend to use letters rather than random squiggles that I make up on the spot. So the difference between an equation and a function, obviously they both have an equal sign, but in an equation your equal sign is equals two expressions at most, whereas a function, which is why we no, that's a pound sign, it's why we normally use f of x rather than y, because y could be considered another variable, equals something like this. We are considering how that expression changes as the value of x changes. I've talked a lot about variables. I should probably explain what a variable is. So in the expression x plus 3, obviously x is the variable. There are two types of sort of values, as it were, in this expression. We've got x, which is our variable, and r3, which is called a constant. No, that's not how you spell it. Constant. So a constant, like 3, is a value that cannot change. 3 has a defined value. If I say 3, you know what 3 is. If I say x, you don't know what x is, in a mathematical sense at least. Obviously, in a literary sense, you probably do. X is called a variable because we are effectively allowed to change the value of x. So for example, we could say, well, let x have the value of 1. And what that means is then we replace every x in our expression with a 1. So we'd go 1 plus 3. Obviously that now has a value that is equal to 4. We could say, well, actually I'd rather x equaled 7. So we could then do 7 plus 3 equals 10. These are both values of the expression x plus 3. So if we're dealing with something like f of x equals x plus 3, to mathematicians that means we are interested in how the value of x plus 3 changes as the value of x changes. So this is not a particularly interesting function, but this is basic algebra, so they get more interesting, I promise. Whether that's a promise or a threat, I leave up to you to decide. So, those are the three fundamental terminologies you need: expressions, equations, and functions. There is also some notation that is crucial. Mathematicians use it all the time because we're lazy, and that this sort of stuff you need to know. So, if I write something like 2x, what I really mean is 2 multiplied by x. This is slightly confusing at first, I suppose, because 23 does not mean 2 times 3. But to mathematicians, 2x just means 2 lots of the unknown quantity x. If you really want to think about it properly, you could consider having brackets around the x in the same way that 2 brackets 3 does equal 2 times 3. Obviously, it's worth noting 2x is the same as x plus x. Similarly, 3x is the same as x plus x, or 3 times x. Next notation might not be too surprising, but if we have something like xy, these are two different variables. Mathematicians never use more than one letter to represent a variable. At least for now. You get subscripts later on, but ignore those for now. Just one letter per variable. So xy equals the variable x times the variable y. You may also see some people will write it as x dot y, with a dot representing multiplication. Both are fine. X and y in this case are going to both be what's known as scalars, which means they just have a value. Something like 3 is a scalar, 7 is a scalar, minus 419 is a scalar. Anything that's just a number is a scalar. Scalars are contrasted with vectors, which are lovely, beautiful geometry things that you do not need to know about for now anyway. And the only difference is they have direction, and therefore multiplying them is a little bit harder, and there are two ways of doing that. But for algebra you can use cross multiplication or dot multiplication, or most people will just write the two next to each other and everyone knows that's multiplication. The other notation it's worth knowing, something like x squared means what you'd think it means. Obviously something like 2 squared equals 2 times 2, so x squared equals x times x. X cubed equals x times x times x, and so on, and you get things like the square root of x means what you'd think it would mean. X to the 3 halves means exactly what you'd think it means. Square root of x times the square root of x times the square root of x. That is, of course, the square root of x cubed. Powers work exactly the same way as if they were on normal numbers. Of course, they are on normal numbers. They're just on normal numbers whose value we don't know. Watch out if you have expressions like this, x squared y. This means x times x, that's the x squared bit, times y. If you're ever unsure, always break it down. Well, I've got an x squared and I've got a y. I know the y, they're multiplied together, so we've got x squared times y, and then I know the x squared is just x times x. So you can string them all together and you get x times y. Similarly, if I have something like x to the 5th y cubed, that is obviously x times x times x times x times x. That's my x fifth, x to the 5th power, times y times y times y. That's the y cubed. Exactly the same. The final thing I want to talk about in this introduction to basics of algebra is brackets. Don't tend to see brackets that much outside of algebra, at least at this point, but in algebra they are crucial. If I have something like I showed earlier, 2 times 3, or 2 brackets 3, that 2 is called a coefficient. What it means is you just multiply everything in the brackets by that 2. So here, that's going to equal 3 times that 2, which equals 6, as we saw earlier. That works exactly the same with variables. If I have 2 brackets x, that is going to be 2 times x, or just 2x. And similarly, that would be the case if it was x times 2, which equals 2x. Because multiplication is commutative, which means that x times 2 equals 2 times x. Don't worry about which way round you write it, it works. You can do this with all sorts. If I had a bracket that was like 2 times 4 minus 1, obviously I can calculate the bracket first and do 4 minus 1 being 3, and then we know that's 6, or I can multiply everything in the bracket first, which is going to equal 2 times 4 minus 2 times 1. Always watch the signs. Technically that should be plus 2 times minus 1, but the minus comes out and makes it negative anyway. I'm going to keep it as plus 2 times minus 1 for now, actually, because it's clearer. Anyway, 2 times 4 plus 2 times minus 1, obviously 2 times 4 is 8, 2 times minus 1 is negative 2, and then 8 minus 2 is 6. Again, the maths works. Doing it this way is important when you have unknowns, because you can't always just solve the brackets first. So if I had something like 4 times x plus 2, obviously I don't know what x is. I can't just do x plus 2 and then multiply that by 4. So I'd have to do 4 times x plus 4 times 2, which obviously equals 4x plus 8. Sometimes you want to write things in this form. Sometimes you'll want to write them in this form. It depends on the situation. Final point of this lesson is that coefficients for unknowns tend to be written as fractions rather than decimals. So I can have x divided by 3 is exactly the same as x over 3, which is exactly the same as 1/3 times x. You will normally see that as 1/3 times x, or possibly x over the 3. Depends on what is trying to be conveyed. What you will not see is 0.333 ... x, 0.3 x, 0.3 x, anything like that. They will always use 1/3 or sometimes x over 3. You're unlikely to see x divided by 3 unless it's just a very simple equation like x divided by 3 equals 4, that sort of thing. So that's it on the basics of algebra, taking you through some of the terminology and some of the notation, and some of the nuances as well. My next lesson, which will be next week, I promise, I'm back at it now, remembering stuff. My next lesson will be on some of these basic algebraic equations, how to solve them. Until then, look after yourself.